João, sound is good?
Yeah.
Okay. We're now ready to start. Welcome for joining us today in another Connect Together session. Today, I have with me João. João, thank you very much for joining us.
Thank you, Nicky.
And we'll be here talking about our fire-rated weatherproofing system. Yesterday, for instance, we were talking about breathable membranes, and today we'll be more focusing on the fire performance of our system. So, playing with our with the most performance to fire, the elements that we have with the better performance to fire, and joining them in order to get the best system, the best entire and complete system when it's concerning to achieve a better classification in terms of fire. So I would also just like to remember that you have available a chat box that you can access in order to place any question that you find important. And so please feel free to do so, as we'll be more than happy to support you with those queries. So moving forward here. So again, as we've been saying every time we are talking about Rainscreen cladding, we have every time these really pretty finishes. So everything seems good, seems fine, with a great performance, but aesthetics is not, of course, everything. And so we need really to understand what's behind it. And when it's concerning to fire, we've been hearing lots of discussions around the cladding behavior to fire. So about Grenfell, of course. So every combustible cladding was put into discussion. And so we are here, of course, in which concerns to our expertise and portfolio in the weatherproofing systems, looking to everything that goes just behind the cladding, and still in regards to fire, as I mentioned before, this is our topic for today. So just highlighting a few pictures from recent events that unfortunately happened in the world. And so we can see that many failures reached to a point where the fire was just impossible to control within the building, and most of them starting or spreading through the facade. And so here we have some of the information, some numbers, mainly focusing on injuries and deaths. So we have in those events many losses, and this is something that we need to care about, of course. And so some covers from newspapers. So just focusing on this kind of information, because this is really an important matter to be discussed. And here, I would just, before entering the layers of the facade, etc., I would like you just to take a look at these pictures, because this just shows that when it comes to understanding the behavior of fire in a facade, the way it can be spread, the things that can influence the way it behaves. This is just a really wide topic to be discussed. So this is not a linear approach. We really need to understand many things, and still it is not that clear so far regarding fire and how we can really reach the different levels and spread all over the facade. So here we can, for instance, see some pictures and look at them, like here. So the ignition, so the source of fire is coming from the outside of the building. So it's an outside source. Here we can see the fire starting at balconies, so with organic materials that we always have on there, and so the fire starting in there, and then here just the fire spreading through from floor to floor. For instance, an explosion on a kitchen or something that just happens and brings the fire to the next floor. Here we have some an interest effect that happens when we have, for instance, a ventilator facade that is creating this kind of chimney because we have airflow and oxygen just flowing behind the cladding, and this will, of course, take the fire to upper levels. Of course, we know that now we have different ways of controlling this spread, but this is something that we really need to take into consideration. Okay, the same in here. So airflow just taking the fire through this camera, and then how the architecture of the building is, it will also affect the way the fire behaves and spreads from floor to floor. For instance, if you have projecting elements on the facade, it will be difficult for the fire to go up to the next floor, as if you don't have nothing and it's only a plain facade, for instance. And also this kind of inclination that you may have on your facade can also affect the way it spreads all over the building. Another architecture feature that would influence the way the fire spreads is this shape, this U shape that you can have on a building. That for sure will turn it into a worse situation here, just in the middle of this building. And then just understanding also the winds, the airflow speed, so everything that is dealing with taking the flames and the smoke and everything to other floors and to other divisions. And so this is just to mention again that this is an open discussion. Okay, we need to understand many things. And what the market or the main response from the markets is being given by this kind of regulation. So regulation that is also pretty much discussed is not, I would say, not everyone is in accordance with this regulation. So that's a lot of discussion. And here we have some shots just so some mentioning regarding the two main markets that we are involved and that we have been requested many times in terms of fire, that is the UK market and the Middle East. João, would you mind just sharing a little bit what what these regulations are asking right now in terms of fire?
Of course, Henrique. So in terms of regulation, it's important to mention that we've seen a push mainly because of these events that you mentioned. So specifically in UK market, Middle East market, so it happened a lot of this fire events. So every time that those events continues to happen, we always going to see a push when it comes to the regulation. For instance, we see at the time a minimum of a classification for a high-rise building of a class B for 18 meters tall. But this is something open to discussion, as you see, because how about something a little bit taller, less taller in this case? So we're always going to see changes on the terms of regulation. In this case, we see, for instance, the building regulation, so a minimum classification, as you see, for A2 S1D0 or A for the external wall. But this will be changing. We see a lot of push in terms of the amendments. It's important to see here in the industry that sometimes those technology or those materials are not even available. So the industry must be continuing developing, trying to improve all the materials, the newest technologies. To fulfill these future gaps. It's just to look in the future, always trying to keep up with the good Patricks and trying to bring something new that is not even already asked, because as we see, uh, the technology we have is available since 2011, part of it that we discussed later on this presentation. But until just a couple of years ago, it was requested, it was an amendment.
Okay, and regarding gaskets and window sealing membranes, it's also not clear topic, right?
Yeah, it's a open to discussion thing. So this is you saying is this is gasket or EPDMs is a sealant, is a part of the window. So it's an open to discussion thing. It's not very clear. You have people saying very pragmatically saying it's absolutely not. It's something different. And then it's open to discussion in Hiki. So some people
Okay.
saying it is part. Some others say it's not.
Yeah, and I suppose this will maybe the best conclusion is that these regarding gaskets and these membranes, that some of them are exempted from this regulation. That this should be studied project by project, because sometimes we have like um, a membrane, an EPDM just going from the bottom to the top of a curtain wall, like just connecting from glass facade to an existing building, for instance, or
Absolutely.
something.
So when we have, for instance, just around the window, we have, for experience, we know that this is not going to propagate. It's just going to burn if it's the case, and only around that frame. It's completely different. For instance, as you're saying, if we have a curtain wall. So again, we need to analyze detail by detail. We have a couple of data that we're going to show later on, saying that some of our products help to reduce the combustibility of some of the materials. So we need to analyze it.
Okay, and also just to briefly mention that in the UAE, where I have many projects, the weather is completely the opposite, right? We have warm on the outside and humidity, high humidity on the outside as well. And so vapor barriers are usually applied on the outside. So when we have like connections, for instance, between windows, we use products that are vapor tight, so that cannot be that are blocking the vapor to access within the building facade. And so here just mentioning that vapor barriers shall be aluminum foil or achieve A2S1D0. So very restrict, I would say, regulations in the UAE regarding this kind of use of combustible materials on a facade. And that's it. Thank you, João. Also some mentioning about bitumen and so also different combustible membranes that cannot be used. And just very briefly, as we've been saying in all our presentations, mass production is the type of the system, the market, how the market is going just right now. So we have very standard products reaching the customers as a possibility to buy, but we don't have this discussion on what is important or not for the project, and the flexibility from the manufacturer to adapt to the project needs. So this is something that we find very important, to have this interactive dialogue in order not only to provide a good solution to our client, but to understand the project needs and to be able to provide the best solution for that project needs. So this is something that we do every time. So again, something that you should be already aware. So we have 4 main divisions within our portfolio of products and our technology that it is available, and our consulting department that is supporting these 4 blocks of information. So Breathable, VCL, EPDM, and prefabrication that is playing with all the wall technology that is available and turning it into bespoke products or products that just fit the very specific needs of each project. Today, regarding fire, as you may know, we have 2 main A2 fire systems, and we'll be just focusing on more detailed information regarding these systems. So we are talking about fully covering the walls of the Rainscreen in terms of weather the outside, so a breathable membrane just outside the insulation layer, and the VCL on the inside, both A2S1D0. Here, so we have just a table like we call it like a product selector. So it's something that you can just easily go through in order to understand what's the best product to be used. And here you easily identify that we have an A2S1D0 fire reaction breathable membrane. So this, as we today are talking about fire, this is the one that we'll be discussing. João, would you mind just sharing some information on this system, please?
Absolutely. So yes, we discussed a little bit more deeply yesterday when it comes to breather membrane. So we all know the importance of having a breather membrane. In this case, is vapor permeable to allow the vapor that's coming through the inside go through the outside of the facade, but still remained as a weatherproofing barrier. In this case, we always recommend in this, if it's applying on the insulation, to be as much dry as possible. So this membrane is a W2. In terms of fire reaction, which is the main topic today, is the best classification you can get currently in the market, which is A2S1D0. As I mentioned, we have this product tested or ready since 2011. So we have a good knowledge on this technology. And so all product fully certified, compliance with the most of regulations. And in this case, I think it's important to mention, is achieve this fire reaction classification tested as standalone, following the 13501 standard. But we went a little further and tried to test it, including the accessories. When I mean accessories, it's for fixing, for temporary fixing, fastening, sealing, of perforation. This is all included. So we did that, including the accessories, and we have tested that is also achieved the A2S1D0 fire reaction classification. So this is very important to understand how this is actually work as a system. So this is why we classify it as a A2 or that FAR system, including the breather, but then the VCL that we're going to discuss later.
Okay, very good. And here also some highlights some of these different performance from this breathable membrane. Would you like to comment this too, João, please?
Yes, and so here we have just a quite table comparison how a standard Class B breather membrane in comparison to our A2. So in this case, you gain a lot, of course, in fire performance. It's important to mention that then even you see as A and then a B, but those two different membranes when it comes to fire performance, they're very, very, very different. You should also understand how the actually standard works, understand how these two membranes works. But in terms of classification, this is a huge jump to understand to go to a B to A2. And then when I was saying, because of the whole properties of materials, this is based on fiberglass, you not just gain a fire performance, you gain a lot of when a tensile and tear resistance. So here in comparison, if you see a standard Class B, when it comes to tensile, you have average 300 to 90, ours go to up to 2000 newtons per 50 millimeters. So this is completely different. Again, this is our very important factors depending how it's installed. If you see, for instance, the CWCT manual, tensile is one of the main characteristics or tier that you should look into it when you're trying to pick a breather membrane, because of how it's going to be installed, how it should hold this type of perforations or tier during the installation, because sometimes it's total exposure for up to 6 months. Again, other characteristics is UV stable. So here's completely different. He could just to pick up these three main technical characteristics. What I always recommend is to, if it's necessary, we can send all the data or the technical data, and to just have a quick comparison between what the standard market provides, which is mainly Class B, in comparison to ours.
Okay, very good, João. So indeed, mechanical resistance is very important, as we understand that the breathable membrane will be, as you were saying, exposed for many months, direct exposed to the weather, to wind, to everything. So it will be pushed, it will be tried teared off through the brackets. So it's really important. We every time see damaged breathable membranes just on the buildings, on the facade. So it is really important they are able to keep their condition as it was supplied for as long as possible, and having these kind of values are of course a really interesting achievement for this kind of membrane. And so just some pictures of this very specific system being installed in UK projects. And so we have different kinds of projects, so from residential to universities to shopping centers. So we have here different kind of installations. So many of the requirements, of the demands, of the queries that we'll be receiving, that we have been receiving, are related to so keeping the fire away from people's lives. So for instance, residential is a very kind of buildings that are requesting this kind of membranes, of performance. So we'll just go just now through the vapor FR system. That is our VCL, also fire rated. So we can easily, looking at this information, understand that there are both the same thing has been done to this system as Joao, you were saying, for the breathable membrane. So also here regarding the VCL, the same classification was achieved, so A2, S1, D0, and again, not only the membrane, but the fastening, so the fixing tapes, the overlapping tapes, the perforation sealing, so everything in the system was tested as it was with the breathable membrane, right? So that's
right, Enrique. And here, this is something that we develop later on during this process. Since we already have the technology ready, available and made for the breathable membrane, we use the same expert, we use the same technology to come up with the VCL. So in this case, we're very proud to say we're the first one in the market to bring this A2 S1D0 VCL. And it's pretty much based on the same components, again, fiberglass, aluminum. This is the base composition of these materials. And as you're saying, tested again as a system, achieve this fire reaction classification, including the whole accessories for fixing, fastening.
Okay. And of course, when you're talking about the VCL, we want it to be a vapor barrier, but also understanding that he has some good performance in terms of watertight and airtight. So many of them are really watertight and airtight. And when we're talking about this very specific VCL, we know it has, and we will be able to look at these kind of values later. So for instance, water vapor resistance is really high. So what would be a standard VCL, João? In terms of material, we've been talking of plastic.
Yeah, polypropylene, stuff like that. And this is usually polyethylene. So usually it's around 200, 300, the water vapor resistance. This is the SD value. And ours goes to up to 7,000. And we can confidently say it's even more. It's actually the standard that we use, which is the DN 1931. It's quite complicated to replicate or to attest for all products because of the whole composition, since aluminum is very tight. So we did it after a long time testing the samples, and we achieved this value as you see here, 7,500.
Okay. But also, so this may be possible because of the aluminum composition, or the presence of aluminum. but we are also taking advantage of our fiberglass in order to achieve these very different tensile strengths, right? This is about
absolutely.
Because of the
So
fiberglass.
yeah, in this case, you usually say a standard class B is polyethylene 400, 350. Ours go to up to 700 again because of the fiberglass. If you see the breather, has even higher. But this is a thinner material. It's different. It has fiberglass on it, but it's completely different in a way when the mechanical resistance. But we can comfortably say it's at least twice as higher as a standard bleed.
Okay, thank you very much. So here we can see some pictures taken from sites when we see the VCL already installed, and we can understand the sealing with the slab was done. Okay, and I can let you know that it was done through self-adhesive double side tape. So we have here a very easy installation procedure. So just applying a line of tape and then connecting the VCL to the top of the slab. And all these connections, all the overlapping tape. So every single accessory that was used here, as Joao was saying before, this was included in our testing. So when you are looking at this final installation, you are looking at a system that is fully approved, that was fully tested, not only the membrane, not losing topics. So we have everything studied, we have everything tested, and we can see later on just some of this testing being represented. And so just having a quick look into the method statement of these two fire-rated systems, and mainly to understand that this is not more than a current installation procedure in terms of installing this kind of membranes and systems. So these pictures are applicable to both systems. So the first conclusion is that both systems are applied in a very similar way. Okay, we are talking about similar base material, like Joao was saying. So it is fiberglass based material, and so this allows us to take advantage of some specific accessories and use the same accessories in both systems. And this is a large advantage when at site we are playing with the full system. Okay, we don't have that many different accessories to provide to the site and let them use them in the best way they can in order to don't mess up. So here no confusion possible. And so we have tape here. So we have a tape for the fixing lines. So single line spaced half a meter from each other. You just apply it directly on the substrate. Normally it's the CP board, and then you have overlapping details, vertical and horizontal. Two lines in this case of the very same tape, and you just apply it like this. So having this concept, this easy concept of going with the upper row.
Here the main thing. Here the main thing is just to mention that even though we have different materials, different base materials for both membranes, the installation is quite simple, quite standard in comparison to others. And again, we provide all this information for installation, even including site training.
Yeah, it's exactly that. And here we can see also that some of the details that we were, for instance, yesterday highlighting for the breathable membrane. So this is exactly the same today with these fire-rated products and systems. So when we still have to deal with this kind of perforations, for instance, these bracket sealings, we can still use the same tape that we were discussing yesterday, so the 2-bond DS tape, and still achieving the A2S1D0 classification as a system, right, Joao? So
right, that's correct.
It's just that. So as we were saying, both systems were approved as a system, so full all accessories included. These are some mock-up drawings used for the testing. where you can see the different tapes used. Then here, regarding EN 13501, we can see so some pictures taken from this test. So this ignition source, this single burning test, where we have this fire and understanding how the fire propagates through the membrane. But also we need to test each accessory of the system through this calorimeter test. So of course, these accessories are already installed in these mockups, in this just here in this panel. But we also have to assess this calorimeter performance or value for each accessory single test, so a test alone. And we understand that the results are exactly the ones that we have been discussing. So not only A2, what means that it's non-combustible material, so limited combustibility. It does not take the fire to anywhere else. But also regarding droplets, it's no droplets created, so D0, and S1, which means very less smoke, very low smoke production from a fire that is happening on the membrane or being applied to the membrane. So A2, S1, D0, that's the final classification. João, here we have a mock-up test, so a full mock-up test.
So besides the standard, which is the 13501, for some specific projects and from specific products, in this case the Breathable, we have a couple additional testings. In this case, we decided to go for the BS 8414, which is the British standard, very, very well known in UK, which replicates a full-scale mock-up test. In this case, we have a cladding system applied with our Breathable membrane, and in this test we see is trying to simulate just like a break of a window in the ground floor when you have just this fire chamber. And here is try exactly to replicate these situations to see how this is actually work on a facade. So in this case, you see up to the first floor or the second floor, the cladding itself completely burned in that part. But our Breathable membrane, just with a slightly different shade of yellowish, in completely intact. So you see here how actually this works. And again, it's protecting all the materials behind.
Okay, very good. Very interesting test, just very specific to a project, for a project. So
Yeah,
this is also something that we have done in order to support our Middle East market. So ASTM E84 is the standard applied to that market, so followed by that market. And we can see here, João, that the results were already quite good, right?
Yeah, so this is a American standard, but as you're saying, it's largely applied in the Middle East. So we have a project there in this case, and we did to see, so there's many tests to check the flame spread and smoke development. This is one of the main ones. So it's basically a 24 inches by a 20 feet sample, so a very long sample. In this case, it's applied our materials, and this sample goes through a Steiner tunnel. And here, inside the tunnel, they tie, this is a completely closed out Steiner tunnel. As you see here, this is right next to the tunnel. You see kind of here the windows. So the tunnel itself is pretty much the same size of the sample itself, 24 feet long. So you put the sample inside the Steiner tunnel, and then this is a completely ignition, it's completely burned. And what we see here, we have this little table to reach the classification 1 or A. You have to have a flame spread to 0 to 25. In our case, we had a flame spread index of 5, which is very, very low and still inside of the classification 1 or A. And same thing here for the smoke development. So you see it goes 0 to 450. In our case, it goes to 15, which is really, really low. It's almost as just low as you can get for this type of testing. So again,
Yeah.
smoke development and flame spread is something really important. We see how actually, Henrique was mentioned in the beginning, how actually the fire propagates in some cases on the facade. So having a material with this type of testing is really important.
Okay, so not only an A classification, but also a very good A classification. So really
Absolutely,
close to
absolutely.
zero, much more closer to zero than to the border
Max
with
max
the.
variant, yes.
Yeah. Okay. So this is just a very specific application that we had. So a very specific, so a project, a very demanding project, was asking us to provide a solution that was able to improve the facade fire performance, but having very, very combustible material on the back of the facade. So we would need to, we could not remove those combustible materials, but then we would need to cover them with our membrane. And so, as we were saying, we are playing in the Middle East market in this case, and so we just came with our paper FR membrane, and it just cover it. This is exactly the same test, right, Joan?
Yes,
But
Henrique,
with the
this is exactly the same test. Here, what which the client have this Grace Ultra membrane, as you see, which is a bitumen self-adhesive membrane, a very, very combustible membrane. And the project demands, because the new amendments and all the regulations we see, it will be very, very complicated to remove all of these membranes, since it's a self-adhesive membrane. So we decided to go for testing, the same testing I mentioned at the breather, but in this case, using the vapor FR, covering the Grace Ultra membrane. And we went for testing again inside this standard tunnel. And what we see here is the behavior of this flame spread smoke development. So we have for both flame spread 0, smoke developed 0. So when I was mentioned that all materials protect the combustibility of other ones, this is actually what I was saying, and not only that, because of other testing that we have done to actually understand how these materials work. So this is very interesting and Hickey to see. So
Yeah.
it's very important for this project to have to see that actually we come up with a solution, just instead of replacing, having all this repairing work, we just place our membrane on top of it to see how it actually will work.
Yeah, and indeed, it was improving the facade efficiency fire, and of course, this was applied this way. Okay, thank you, João. So I have here some projects. I know that we became also short in terms of time. I will just have a quick overview of the project. So these are UK projects, Ireland projects that we are just showing, so featuring VCL and breathable fire-rated membranes. Here also in the UK, so residential buildings, without saying, this is very important when it becomes to fire to protect these lives. And here, King's Cross, for instance, and Elephant Park, just in the heart of London, also featuring this fire-rated classification. As we were saying, we have also projects ongoing in the Middle East. So we have here some of them being shown up. So, for instance, this one is for Expo 2020. 2020. I suppose it's 2020. No, João?
Yes, yes.
We're not sure right now if
Still.
it's going to happen or not, but it's still the same name. And so some articles that we constantly release and post in our website, so you are more than welcome to access them. And just finishing and taking advantage to thank you all for attending. I have here my contacts, my email, my phone number that you are more than welcome to use and to access in order to reach more information. Tomorrow we'll be talking about VCL at the same time as we do every day. And so please feel free to access. We also have some feedback that you can give through our website. Okay, you can just access to the connected value page and leave there your feedback. You can also, I think you also have a link just on the chat box. Yes, so please feel free to do so. Thank you, João, for being with me here today.
Thank you.
And hope to see you on the next Connected Value session very soon. So thank you very much.
Bye. Thank you.